Tonight, as you settle into a comfortable position and allow the last traces of the day to drift away from your mind, I invite you to enter a world where even the most powerful forces of nature reveal their gentlest side. Volcanoes, symbols of fire, movement, and transformation, are often imagined as loud, violent, and unpredictable. Yet when we slow down, breathe deeply, and look at them through a softer lens, we discover something entirely different, a quiet story of creation, rhythm, pressure, and ancient calm. Imagine yourself standing at a safe distance, watching a distant volcanic landscape at dusk. The sky is painted with soft tones of lavender and gold. The air is still and pleasantly cool, and ahead of you rises the silhouette of a massive volcano, not erupting, not rumbling, but resting. Its slopes are covered in forests and delicate grasses. Its peak touches the fading light like a quiet monument shaped by time. Nothing about this scene feels dangerous. Instead, it feels grounded, steady, and deeply peaceful. Volcanoes are storytellers. They carry the memories of Earth's earliest days, when continents were only beginning to form. They shape landscapes slowly, patiently, building mountains grain by grain, layer by layer. Lava, when flowing gently, moves like thick, glowing honey, creating new land with every ripple. Ash settles onto soil like soft snowfall, enriching it over years and decades. Even volcanic gases rise quietly into the sky, becoming part of the atmosphere's slow circulation. As you listen tonight, think of volcanoes not as explosions, but as breath. A slow inhale beneath the ground. A long, patient exhale through vents and fissures. A rhythm that mirrors your own breathing as you prepare for sleep. This is the quiet story of volcanoes. A story of warmth, creation, and deep time. A story that unfolds gently, guiding you into rest one soft detail at a time. Let the stillness of ancient mountains settle into your body. Let the calm of molten rock cooling beneath the earth wrap around your thoughts. And let the planet's slow movements carry you toward a night of deep, peaceful sleep. When we think of volcanoes, we often imagine eruptions, glowing lava, rising ash, trembling ground. Yet the true story of a volcano begins long before any of that. It starts deep within the earth, in a place where movement is slow, temperatures rise steadily, and pressure builds not with violence, but with patient persistence. Tonight, we travel into this hidden world beneath the crust, exploring the calm, ancient processes that give birth to a volcano. Imagine descending slowly through layers of rock. The world grows warmer, softer in color, more fluid in rhythm. The Earth's crust, a thin shell compared to the planet's size, fades above you. Below it lies the mantle, a vast region of rock that is not solid nor liquid, but something in between. It flows so slowly that its movements are measured not in minutes or hours, but in millennia. This slow motion, almost imperceptible, is the foundation of all volcanic creation. Here, the story begins with heat, deep primordial heat left over from the birth of our planet, combined with the heat produced by radioactive elements breaking down in the Earth's interior. This warmth is steady, constant, and patient. It has been flowing outward for billions of years, shaping everything above it with gentle persistence. When this heat rises through the mantle, it causes the rocks there to behave like thick, soft wax, drifting upward in slow, wide currents. As mantle material rises, something remarkable happens. It begins to melt, but the melting is not sudden or explosive. It occurs because the pressure decreases as the rock rises toward the surface. When pressure drops, minerals inside the rock begin to separate, forming droplets of molten material, magma. These droplets gather, collect, and merge into larger pockets of melt. Magma is born not through chaos, but through gentle release. These pockets of magma can remain deep underground for thousands or even millions of years. They rest in chambers, slowly evolving, cooling, heating, and mixing. Some chambers grow. Some collapse. Some stay dormant indefinitely, never reaching the surface at all. The Earth is full of magma that will never erupt, reservoirs of molten rock that simply exist in quiet darkness. What determines whether magma rises toward the surface is a matter of balance. Magma is usually less dense than the surrounding rock. So, like a bubble rising through thick syrup, it begins to move upward, but the ascent is not fast. Magma pushes through fractures, cracks, and weaknesses in the crust, inching upward over centuries. It pauses when it reaches a layer too dense or too cold. It collects again, forms new chambers, and waits. This slow migration is one of the most peaceful processes in geology, a quiet ascent guided by physics and patience. Pressure builds only gradually. The rock surrounding the magma adapts, shifting its weight, opening pathways, closing others. The crust breathes in response, expanding and contracting with the movement below. Eventually, a volcano begins to take shape. Some volcanoes rise at tectonic plate boundaries, where plates pull apart or collide. Along mid-ocean ridges, magma rises to fill the gaps left by separating plates, creating new seafloor in a process so gentle and continuous that we rarely think of it as volcanic. On continents where one plate slides beneath another, melting occurs deeper, and volcanoes form arcs of mountains, each shaped by slow, steady processes beneath. Other volcanoes form at hotspots, places where mantle plumes rise from deep within the earth, bringing heat upward like a long, warm breath. These plumes remain in place while tectonic plates drift above them, creating chains of volcanoes over millions of years. The Hawaiian Islands are one of the most peaceful and elegant examples of this. A trail of mountains formed by lava that once flowed gently from the seafloor. When magma finally reaches the surface, it emerges through a vent, fissure, or crater that has slowly formed through the stretching and cracking of the crust. The opening may begin as a hairline fracture. With time, it widens. The Earth's surface gently adjusts to accommodate the rising magma. Some eruptions are explosive, but many, perhaps most, are quiet. Lava flows out slowly, like glowing rivers of thick syrup. Gas escapes as soft hissing. Ash drifts upward like delicate dust. These gentle eruptions create broad shield volcanoes, lava plateaus, and smooth slopes that stretch for miles. They build land not in bursts, but in slow, steady layers. Even explosive volcanoes have calm phases. The build-up to an eruption must occur over long periods of pressure accumulation, gas separation, and chemical evolution. Volcanoes spend far more time in rest than in activity. For every moment of eruption, there are decades, centuries, even millennia of quiet stillness. This stillness is where most of a volcano's life unfolds. A volcano may sit silent, its slopes covered in forests, its crater filled with snow, or a calm lake. Wildlife adapts to its contours. Rivers carve paths across its surface. Plants root themselves in soils enriched by ancient eruptions. People may even live along its flanks, unaware of the magma reservoir resting deep below. Volcanoes, even when dormant, continue to shape the world. They warm groundwater, creating hot springs and geysers. They release gentle plumes of steam that rise like breath into the sky. They build landscapes layer by layer, giving rise to ridges, valleys, and fertile plains. Every part of a volcano's existence contributes something: heat, minerals, new land, or quiet geological tension that ultimately drives the planet's long-term evolution. When we look at a volcano through this perspective, its story becomes less about fire and danger, and more about patience and creation. Volcanoes are creators of continents, sculptors of islands, guardians of deep time. They write the history of our planet in rock and ash, not with noise, but with slow, measured movements. As you listen, allow this awareness to settle gently into your thoughts. Beneath the ground, processes are unfolding that have shaped the Earth for billions of years. Every volcano begins with heat rising softly through the mantle. Every eruption begins as a whisper of pressure. And every mountain formed by volcanic activity stands as a reminder of the Earth's ability to transform itself, slowly, steadily, and beautifully. Take a slow breath. Feel the quiet power of deep time beneath you. And let the birth of a volcano guide you deeper into calmness, knowing that even the strongest forces of nature begin in silence. Volcanoes come in many forms, each shaped by the slow, methodical movements of the Earth beneath them. Though they may appear dramatically different from one another, every type of volcano grows through calm geological rhythms. Their shapes can reveal their histories, how lava flowed, how ash settled, how pressure moved, and how time sculpted them into the quiet giants we see today. Tonight, we will explore these shapes gently, not as fiery mountains, but as soft silhouettes rising from different landscapes, each with its own quiet story. Imagine yourself standing before the first type, a shield volcano. These volcanoes are some of the most peaceful on Earth. Their slopes are gentle and broad, stretching outward for miles in smooth, flowing curves. From a distance, a shield volcano looks almost like a sleeping creature curled beneath the sky, wide, calm, and unhurried. Shield volcanoes form from lava that is thin and fluid, able to travel long distances before cooling. When this kind of lava emerges slowly from vents or fissures, it spreads outward like a warm blanket, layering the landscape over and over again. Each flow adds only a thin sheet of new rock, but over thousands or millions of years, these sheets build vast mountains. Hawaiian volcanoes such as Mauna Loa and Mauna Kea are perfect examples, mountains so large and gently sloped that they seem to merge with the horizon. Their eruptions are often quiet, producing glowing rivers of lava that move like slow streams at night, illuminating the darkness without chaos. These volcanoes show that volcanic creation can be tranquil, elegant, and deeply patient. Now shift your attention to a different shape entirely, the stratovolcano, also known as a composite volcano. Stratovolcanoes rise sharply, forming tall, symmetrical peaks with steep sides. They are the classic volcanic silhouette, the shape that appears in storybooks, paintings, and ancient myths. But despite their iconic form, their growth is not dramatic. Instead, they build themselves layer by layer, like pages added slowly to a long book. Each layer is made of alternating materials: thick lava that cools into sturdy rock, followed by ash and fragmented stones from past eruptions. Over long cycles, these layers stack up, not in sudden bursts, but through repeated patterns of activity and rest. Even volcanoes known for explosive eruptions spend most of their time in stillness. Mount Fuji in Japan, Cotopaxi in Ecuador, and Mount Hood in the United States all stand quiet for far longer than they erupt. During those silent centuries, forests grow along their slopes, snow settles into their craters, and rivers carve paths around their bases. Their stillness defines them more than their rare moments of activity. Next, picture a low, wide formation spread across the landscape like a softly rising plateau, the lava dome. Lava domes form from thick, slow-moving magma that barely travels once it reaches the surface. Instead, it piles up near the vent, cooling into rounded mounds with cracked surfaces. These domes grow like slow breaths, swelling outward over months or years, then solidifying into smooth, bulb-like shapes. They are some of the calmest volcanic formations, rarely producing large eruptions. Instead, their growth is inward and upward, like a plant thickening its trunk over time. When viewed from a distance, lava domes resemble gentle hills, often surrounded by forests or quiet fields. Now move your mind to landscapes shaped not by single mountains, but by long fissures in the earth. These give rise to fissure volcanoes, which create curtains of fire rather than central peaks. But don't let the phrase curtain of fire mislead you. Though dramatic in imagination, fissure eruptions are often some of the most peaceful volcanic events. Lava emerges along cracks in the Earth's surface, flowing steadily into expansive plains. These eruptions build broad basaltic fields, creating flat, open landscapes that stretch to the horizon. Iceland is one of the best places to witness these soft volcanic forms. There, lava flows spread like ink across the ground, cooling into dark stone that becomes home to mosses, lichens, and delicate grasses. Fissure volcanoes remind us that volcanic activity isn't always a towering mountain. Sometimes it's a simple line in the earth, breathing quietly. From fissures, we move to something smaller, almost playful in scale, the cinder cone volcano. Cinder cones look like perfectly formed miniature volcanoes, round, symmetrical hills with craters at their summits. They are built from small fragments of rock, ash, and volcanic glass that fall gently around a vent, creating a mound that grows upward like a soft pile of sand. These volcanoes can form surprisingly fast, sometimes within months or years. But after their creation, they often remain still and unchanged for centuries. Grasslands grow around them. Trees take root along their flanks. Animals wander across their slopes. Their quiet permanence adds charm to volcanic landscapes worldwide. Now imagine a wide, shallow depression in the earth, calm, circular, and serene. This is a caldera, one of the most impressive and peaceful volcanic formations. Calderas form when a large magma chamber empties and the ground above it sinks. Though this process can be associated with major eruptions, calderas spend the overwhelming majority of their existence in tranquility. Many fill with lakes, creating some of the most breathtaking scenery on Earth. Crater Lake in Oregon, formed within a caldera, is a perfect example. Its water deep blue and still, reflecting clouds like a natural mirror. Yellow trees, meadows, and forests surround calderas, transforming them into sanctuaries for wildlife and pockets of serenity for anyone who visits. Even supervolcano calderas like Yellowstone, while geologically powerful, express themselves quietly through steaming vents, warm rivers, and gentle geysers that pulse like the Earth's own heartbeat. Finally, consider the quietest volcanic formations of all, the eroded remnants of ancient volcanoes. Over millions of years, wind, rain, and glaciers wear down volcanic cones, leaving only the hardened magma that once cooled inside them. These remnants, volcanic plugs, dikes, and necks, stand like stone monuments in the landscape. Devil's Tower in the United States, or the volcanic cliffs of Edinburgh's Arthur's Seat, reveal the inner skeletons of volcanoes long gone. These structures have seen oceans rise and fall, ice ages come and go, and forests appear and vanish. They outlive their eruptions by immense spans of time, becoming part of the peaceful landscapes we hike, photograph, or simply admire. Across all these forms, shields, stratovolcanoes, domes, cinder cones, fissures, and calderas, one truth remains consistent. Volcanoes are sculptors of beauty. They shape islands, mountains, valleys, and plains. They enrich soil with minerals. They create habitats for countless species. They form some of the most awe-inspiring vistas on Earth. But they do all of this not through suddenness, but through slow, steady, geologic rhythm. As you envision these shapes now, let their quiet stability anchor you. Let the slopes of shield volcanoes calm your breathing. Let the symmetry of stratovolcanoes soothe your thoughts. Let the softness of cinder cones ease your mind into stillness. Volcanoes, even in their power, are symbols of patience, reminders that creation takes time, that change is gradual, and that beauty often emerges from deep processes hidden from sight. And as you drift deeper into rest, you carry with you the steady silhouettes of these giants, standing peaceful beneath the sky. Far below the ground you walk on, beneath soil, bedrock, and the solid crust of our planet, there is a world that moves at a pace almost too slow to comprehend. Here, in the upper mantle, molten rock flows like warm honey, drifting through currents that take centuries to complete a single loop. This realm is quiet, dark, and ancient, the birthplace of magma and the beginning of every volcanic story. Tonight, we travel downward into this hidden world, following magma's long, patient journey toward the surface. Its movement is not violent or chaotic. It is rhythmic, purposeful, and deeply calm, a geological meditation unfolding over millions of years. To begin, imagine placing your hand gently on the ground. Beneath you lies a planet layered like a serene cosmic nesting doll. First the crust, cool and rigid. Then the mantle, warm and flowing. Below that, the core, where metal swirls and spins. Magma forms in the mantle, where temperature and pressure align to melt rocks just enough for them to behave like a thick, glowing liquid. Even though magma feels like fire in our imagination, its world is surprisingly quiet. There is no roaring flame, no swimming rivers of molten brightness. Instead, magma glows softly, diffused through the partially melted rock. Its movement is slow, inches per year, sometimes even less. For magma, time is an endless horizon, and patience is its constant companion. To understand how magma rises, picture a warm bubble inside a pot of cooling wax. The bubble is lighter than the surrounding material, so it rises, not quickly, but gently, drifting upward because density guides its path. Magma behaves in a similar way. It rises because it is less dense than the solid rock around it. This simple principle drives one of the most influential processes on Earth. As magma moves upward, it encounters cooler rock. It pauses. It gathers. It forms magma chambers, reservoirs that may lie beneath volcanoes for centuries. These chambers are vast underground pockets where different magmas mix, react, separate, and evolve. Minerals crystallize slowly within them, forming crystals that drift like snowflakes inside a warm ocean. Some magma chambers remain forever underground, never erupting, never reaching the surface. They freeze in place and become bodies of beautiful igneous rock, granite, diorite, gabbro, which later appear at the surface only after millions of years of erosion. These frozen chambers are the Earth's geological memories, preserved in stone. For magma that continues its ascent, the journey becomes more complex. The crust is not uniform. It is a quilt of fractured rock, shifting plates, and ancient scars left from past geological events. Magma must find pathways through these weaknesses, cracks, faults, and joints that open and close as pressure changes. This movement is slow and quiet, like water finding its way through a sponge. Sometimes magma pushes the rock gently aside, widening cracks. Other times it melts a narrow path. And often it simply waits, resting in cool pockets until conditions change. As magma rises, gases dissolved within it begin to separate. Water vapor, carbon dioxide, sulfur dioxide, all once trapped under immense pressure, drift upward, forming tiny bubbles. These bubbles increase the magma's buoyancy, helping it continue its ascent. Yet again, the process is gradual. Bubbles grow, shrink, merge, and reappear in cycles that span decades. Even gas movement underground is patient. Eventually, magma may encounter a place where rock becomes brittle enough for fractures to expand. It may push through a long crack, forming a dike, a vertical sheet of magma that slices through the crust like a quiet blade. Or it may spread horizontally between layers of rock, forming a sill, creating underground shelves of molten material that later cool into beautiful geological formations. Some magma rises all the way to the surface through conduits, the main pipes beneath volcanoes. But even here, the process is far from sudden. Conduits may remain partially filled with magma for years, warming the rock around them, creating hot springs, or gently inflating the ground above. Volcanoes often experience quiet inflation, a slow swelling of their slopes as magma accumulates beneath them. Sometimes satellites detect this swelling before humans even notice. The ground rises by centimeters, signaling that magma is approaching, not in a violent rush, but in a careful, steady migration. The pathways of magma also vary depending on the style of volcano. Beneath shield volcanoes, magma flows in broad, shallow tubes. Beneath stratovolcanoes, it climbs through complex networks of conduits and chambers. Beneath rift zones, magma spreads sideways, filling long cracks and creating new crust. Each system is unique, shaped by temperature, pressure, rock composition, and the Earth's slow tectonic dance. Yet the most calming aspect of magma's journey is that it is not linear. It does not march upward in a determined line. Instead, it meanders, pauses, forms chamber after chamber, changes direction, mixes with older melts, and sometimes cools before ever seeing the light of day. Picture a vast underground labyrinth where magma moves like a warm, glowing tide. Its path is influenced by ancient collisions, buried mountain ranges, cooled intrusions, and layers of sediment left from long extinct oceans. The Earth remembers everything, and magma flows through these memories like a visitor passing through a vast library of stone. Eventually, when magma nears the surface, it may begin to influence the world above. Warmth rises, groundwater heats. Minerals dissolve, creating hydrothermal systems that become hot springs, fumaroles, and gently steaming vents. These surface features are like the soft exhalations of a volcano, signals that something warm and patient is working beneath. Even when an eruption is decades or centuries away, magma may send quiet hints, a slight rise in temperature, shifts in gas emissions, or gentle tremors known as harmonic tremors, which sound like distant, continuous humming deep underground. These tremors are not violent earthquakes. They are rhythmic vibrations produced as magma moves through tight passages, humming softly through the crust. These sounds, recorded by seismometers, reveal the calm heartbeat of volcanic systems. They remind us that volcanic activity is not defined by eruption alone. Most of the story unfolds in silence. The journey of magma is a testament to the slow forces that shape our planet. Volcanoes, from their earliest whispers underground to their towering forms above, owe their existence to this movement, a movement so patient, so steady, that it becomes almost meditative to imagine. The Earth is always changing, always breathing, always shifting, not in sudden bursts, but in long geological sighs. Magma rises and falls. Chambers fill and empty. Rocks melt and solidify. And through these cycles, continents drift, mountains rise, and new land is born. As you imagine magma flowing beneath you now, picture it not as fire, but as warmth. Not as threat, but as transformation. Not as chaos, but as time itself. Feel the stability of the planet beneath you. Feel the slow currents of the mantle like waves beneath stone. Feel the calmness of processes unfolding far longer than a human lifetime. And as you drift deeper into rest, let this slow journey carry you, gently, quietly, peacefully, like magma moving through the deep earth, shaping the world with patience. When lava reaches the surface, it feels like the most dramatic part of a volcano's story. Bright, glowing, fluid like sunlight turned into liquid. But in truth, lava tells one of the quietest and most graceful chapters of Earth's long narrative. Lava flows are not explosions. They are movements of warmth, texture, and time. They breathe, spread, cool, and sculpt the landscape in ways so slow and soft that, when viewed patiently, they become almost hypnotic. Tonight, let us follow lava from the moment it emerges into the open air, watching not its intensity, but its gentleness. Imagine standing at a safe distance near a new lava flow. The ground beneath your feet is warm, and the air smells faintly of minerals and distant rain. Ahead of you, a glowing stream of molten rock moves quietly down a slope. It does not roar or rush. Instead, it slides forward like thick syrup, folding and unfolding in smooth, glowing waves. Lava begins its journey the moment magma escapes from underground pressure and meets the surface. But the transition is calm. Lava is simply magma with one difference. It has lost most of its dissolved gases. Without those gases, it no longer bubbles or churns aggressively. It becomes heavy, steady, and beautifully slow. There are two main personalities of lava, each expressing itself with its own distinct rhythm. Fo'io and A, words from the Hawaiian language that describe lava's behavior with poetic precision. Let's begin with Fo'io. Fo'io lava is smooth, silky, and fluid. When it flows, its surface ripples gently, forming textures that look like looping ropes or waves of thick fabric. As it cools, it folds over itself, creating delicate patterns that resemble braided hair or gentle ripples left by water. Watching Fo'io flow is like watching a living ribbon move across the land. It glows softly from within, the cooled skin forming a dark shell, while the warmth beneath continues to push forward. This kind of lava moves slowly enough that plants, insects, and even small animals often sense its approach and move away in time. Fo'io does not surprise the landscape. It announces itself gently, reshaping the ground with graceful continuity. Now consider I, a lava flow with a personality that feels more textured and rugged. I moves like a slow river carrying stones. Its surface breaks into jagged, crunchy fragments as the lava beneath pushes forward. Though it sounds harsh in description, the flow is still incredibly slow, often moving only meters per hour. You could walk beside it without feeling rushed. Each broken fragment cools into porous, delicate rock that crunches softly underfoot once the flow has finally stopped. It shows us that even roughness can be peaceful when it unfolds over long stretches of time. Both lava types share a fascinating feature. They move according to temperature. The hotter the lava, the more fluid it becomes. The cooler it grows, the thicker and slower it moves. This means that a single flow can shift personalities as it journeys downhill, starting as a glowing, silky stream and ending as a dark, stiff crust. Now, imagine following a lava flow from its source. The lava emerges from a vent, glowing bright orange. It moves quietly downslope, widening into small branches. Some branches join again. Others break off and form new paths. Lava never flows in straight lines. It chooses the easiest route, guided by gravity, terrain, and the shapes of the land. As lava continues, it forms lava tubes, natural tunnels created when the surface cools while molten lava continues flowing inside. These tubes become insulated chambers, allowing lava to travel great distances while staying hot and fluid. Inside a lava tube, molten rock moves like a hidden river, silent and warm, unseen by the world above. When the lava eventually leaves the tube or reaches flatter ground, it begins to cool more quickly. Thin outer layers turn solid first, creating crusts that crack and breathe as the hotter interior pushes forward. This slow alternation, cooling, breaking, pushing, spreading, repeats thousands of times until the flow finally comes to rest. Cooling lava creates an extraordinary range of textures. Some surfaces become smooth glass, shimmering like dark obsidian. Others crack into hexagonal columns, forming geometric patterns like natural pavements. Some surfaces wrinkle like fabric. Others crumble into ash-like fragments. Even though all these results appear different, they share the same origin, the soft dance between heat, pressure, and time. Volcanic glass, such as obsidian, forms when lava cools so quickly that crystals cannot grow. This creates surfaces so smooth and reflective that ancient peoples used them as mirrors. Imagine lava cooling in such stillness that it becomes a perfect, polished stone, a moment of transformation frozen in silence. In other places, lava cools slowly enough for crystals to grow. Minerals gather and form patterns visible only up close, like delicate artworks woven inside the rock. Some lavas contain shimmering crystals of olivine, tiny green gems scattered through dark basalt, shining softly like stars embedded in the earth. Lava also interacts gently with water. When lava enters the ocean, it hisses softly as steam rises into the air. New land forms grain by grain as pillow-shaped rocks build quietly beneath the waves. Water cools lava into glassy fragments called black sand, which eventually gather into beaches with velvety, shimmering textures. These transformations are slow, steady, and calm, reminders that lava is not always fiery chaos, but a gentle sculptor of coastlines and beaches. Another peaceful aspect of lava is the land it leaves behind. Fresh lava fields may seem barren at first, but they soon become some of the most fertile places on Earth. Volcanic rock breaks down through rain, wind, and time, releasing nutrients that feed new soil. Plants take root in cracks and crevices. Moss spreads like a soft green blanket. Ferns sprout from sheltered corners. Eventually, forests return, tall, dense, and full of life. This cycle, from molten rock to rich soil, is one of the quiet triumphs of volcanic landscapes. Life follows slowly, but steadily. What lava leaves behind is not destruction, but renewal. Now imagine standing at the edge of an ancient lava field. The rock beneath your feet is dark, textured, and cool. Patterns ripple across its surface, reminders of the lava's slow journey long ago. Small plants grow in the cracks. The wind moves across the stone with a soft, steady voice. Everything around you is peaceful. This is the true nature of lava, a slow-flowing river of creation, moving with purpose, shaping the land with patience. Even the most powerful flows eventually cool into silence. Even the brightest orange fades into shadow and then into stone. Even the harshest textures soften under rain and wind. Lava's story is not one of destruction. It is one of transformation. Molten rock becomes solid ground. Heat becomes habitat. Movement becomes landscape. And time becomes memory. As you drift deeper into rest, let the slow flow of lava guide your imagination. Picture it moving gently across the land, folding into itself, cooling softly, becoming part of the Earth's quiet surface. The planet reshapes itself not through haste, but through ancient patience, and lava is its warmest, softest expression of change. When a volcano releases ash into the sky, our imagination often jumps to dramatic images: darkened skies, drifting clouds, landscapes momentarily covered in fine gray powder. But volcanic ash, when viewed slowly and gently, reveals a story far different from chaos. It is a story of transformation, nourishment, and chemistry that moves like a soft whisper across the land. To truly understand volcanoes, we must explore what happens after the eruption, when ash settles, when minerals cool, and when the earth begins to rebuild itself grain by grain. Tonight, let's take a quiet journey into the world of volcanic ash and the soil it eventually becomes. Imagine standing in a peaceful volcanic valley long after an eruption has finished. The air is calm. The sky is clear. The ground beneath you is covered in a thin layer of fine, light ash, soft as flour, smooth as sifted sand. In your hand, a pinch of ash feels weightless. It drifts through your fingers like dust carried by a slow breeze. Though it seems delicate, this ash is made of tiny shards of volcanic glass, minerals, and pulverized rock, each particle shaped by incredible heat but destined for gentle purposes. Ash begins its life the moment magma is fragmented by sudden pressure release. Inside a volcano, dissolved gases expand as magma encounters lower pressure. These gases separate the molten material into fine particles, which rise into the sky on warm volcanic plumes. But what goes up must eventually come down, not with violence, but with patience. As ash falls, it moves like snow, light, slow, almost floating. A large eruption may send ash hundreds of kilometers away, forming a blanket so thin that it becomes just another layer of dust on a leaf. Closer to the volcano, ash settles in thicker accumulations, forming a temporary gray landscape where every contour is gently softened. Despite its appearance, volcanic ash carries an enormous amount of potential. It is rich in minerals that plants need: potassium, phosphorus, iron, magnesium, calcium, trace elements, essential for growth. These nutrients come from deep within the earth, a gift carried upward by magma and released into the world through ash. But plants cannot use these nutrients immediately. Volcanic ash must first undergo a slow, quiet transformation, weathering. Rain begins the process, dissolving certain minerals and breaking down others. Wind shapes the ash into small dunes. Sunlight dries it. Microbes explore it. Over years and decades, volcanic ash blends with organic material, leaves, moss, fallen branches, forming soil richer than almost any other on the planet. This transformation is so gentle that you may not notice it happening. Yet beneath your feet, the earth is preparing one of the most fertile environments in the world. Consider places like Java, Japan, Hawaii, and Iceland. These regions are home to some of the most productive soils on Earth, not despite volcanic eruptions, but because of them. Volcanic soils, known as andesols, are soft, dark, and full of minerals that plants devour. They retain water like a sponge, resist erosion, and support forests, crops, and wildlife with extraordinary generosity. Coffee, bananas, grapes, tea, and countless other plants grow vibrantly in volcanic regions. Generations of farmers have relied on the quiet power of volcanic ash to nourish their lands. And even forests depend on it. On Mount St. Helens, for example, just months after the 1980 eruption blanketed the landscape in ash, hardy species began to return. Mosses took root first, then flowers, then trees. Within a few decades, the area transformed into a thriving ecosystem once again. The cycle repeats quietly across the planet. Eruption gives ash, gives soil, gives life, gives time. All of it driven by chemistry too slow and soft for the human eye to detect. Now, imagine following ash into the geological record. Over time, layers of ash become pages in the Earth's history book. A thin line of light-colored sediment might mark the distant memory of an eruption that happened thousands of years ago. These layers tell scientists where and when volcanoes were active, how far ash traveled, and how climates shifted. Volcanic ash, even in its stillness, is a storyteller. It also has a unique relationship with water. When ash mixes with rainfall shortly after an eruption, it can form clay-like materials that coat surfaces. Over longer timescales, these clays become valuable filters in water systems. Volcanic clays absorb toxins, bind heavy metals, and cleanse the environment through natural chemical processes. In some regions, volcanic ash forms natural aquifers, porous rocks that store groundwater. These aquifers feed rivers, springs, and lakes, sustaining entire ecosystems quietly from below. Another gentle process begins when ash interacts with wind. Fine grains can be lifted and carried across continents, depositing minerals in remote regions that might otherwise lack certain nutrients. This dust fertilizes oceans, feeding phytoplankton, tiny organisms that absorb carbon dioxide and release oxygen. Across vast distances, volcanic ash becomes part of planetary cycles of air and water. Even volcanic glass, formed as molten rock cools suddenly, plays a role. When broken down into soil, volcanic glass becomes a source of slow-release nutrients. Its sharp edges soften with time, becoming part of the gentle, dark earth that fosters new growth. Now consider the mineral treasures hidden within volcanic environments. Olivine, glowing green like tiny crystals. Feldspar, forming soft white grains. Pyroxene, dark and smooth. Magnetite, shining with metallic luster. These minerals weather slowly into soil, each contributing something unique. Olivine, for example, reacts with rainwater in a way that draws carbon dioxide from the atmosphere, a quiet, natural form of carbon capture that Earth has been performing for eons. The more we explore ash and volcanic minerals, the more we realize that volcanoes are not only creators of land, but caretakers of balance. They enrich the earth instead of depleting it. They rebuild instead of destroying. They offer nutrients instead of scarcity. And they do all of this through processes so gentle and gradual that we rarely notice. Now let's zoom out for a moment and imagine a volcano after an eruption has ended. The landscape may seem barren at first glance, but life is already waiting at the edges. The first arrivals might be hardy grasses, adapted to poor soils. These plants begin to break the ash apart, their roots creating tiny tunnels for air and water. Over time, insects follow, then birds, then mammals. Each new inhabitant transforms the land further. Within a human lifetime, what once looked like a gray, empty field becomes a lush forest or a rich meadow. The soil that began as ash becomes part of roots, leaves, flowers, and fruit. All of this begins with particles so small you can barely see them. All of it begins with volcanic ash drifting gently to the ground. All of it begins with chemistry that unfolds in silence. As you rest, imagine holding a handful of ash that fell from the sky thousands of years ago. Think of all the transformations it has undergone. All the rainfalls, windstorms, seasons, and roots that shaped it. That ash is now soil, nourishing life in forests, gardens, and valleys. The story of volcanic ash is the story of renewal, a reminder that even the most powerful natural events lead, eventually, to calmness, growth, and harmony. Let this knowledge soften your thoughts. Let the idea of slow transformation ease you deeper into rest. And let the quiet chemistry beneath your feet remind you that the earth is always healing itself, quietly, patiently, beautifully. Volcanic landscapes are some of the most breathtaking on Earth, not just for their dramatic history, but for the deep serenity they hold long after eruptions have ended. Many of these landscapes look nothing like the fiery images we associate with volcanoes. Instead, they appear soft, ancient, and peaceful. Mountains resting beneath clouds, crater lakes glowing blue, desert plains of dark rock, and valleys filled with rich soil and flourishing forests. Tonight, we wander through these landscapes with calm steps, letting their quietness guide us deeper into rest. Imagine beginning your journey at the foot of a volcanic mountain, one that has stood silent for centuries. Its slopes are gentle, covered with moss, shrubs, and tall grasses that sway softly in the wind. The air is cool, and the ground beneath your feet is solid and dark. Basalt shaped long ago by flows of lava that are now as still as stone. Volcanic mountains often rise alone, separated from surrounding ranges, giving them an aura of solitude. They stand as reminders of slow geological change, their forms shaped not only by eruptions, but by erosion, rain, and the quiet movements of time. Walk a little further, and you might notice how diverse a volcanic mountain can be. On one side, the slopes may be smooth and evenly rounded, carved by ancient lava flows that poured like thick honey. On another, cliffs reveal layers of past eruptions, bands of rock stacked like the pages of a book telling stories from thousands of years ago. These mountains are more than peaks. They are archives of deep time, shaped by fire, but softened by wind. Now imagine reaching the upper slopes, where trees thin and the air becomes cooler. Perhaps you find patches of hardened lava, twisted into rope-like patterns or rounded formations from old basalt flows. These shapes are so quiet, so still, that it's hard to imagine they were once alive with movement. In the distance, you might hear nothing but wind through the grass and the soft call of a bird. Volcanic mountains carry this sense of solitude, a reminder that power can leave behind peace. But the most tranquil volcanic features are often found at the summit, crater lakes. Imagine standing at the edge of a caldera lake just after sunrise. The water is impossibly calm, reflecting the sky with perfect clarity. Its color shifts between deep blue, emerald, and soft silver, depending on the light. The surrounding crater walls rise gently, embracing the lake like a natural amphitheater. These lakes form when a volcanic crater fills with rainwater or snowmelt. Over decades, they deepen and clear, becoming sanctuaries for birds, fish, and delicate ecosystems. Some crater lakes, like Crater Lake in Oregon, are among the purest bodies of water on Earth, filtering out sediments and minerals until only clarity remains. To sit beside a crater lake is to experience a rare stillness, a silence that feels ancient and grounding. As you leave the mountain, the terrain begins to change. Volcanic landscapes are full of contrasts, shifting from cool waters to dry expanses. Soon you may find yourself walking across a volcanic desert, where black sand or dark lava fragments stretch across the land like an otherworldly carpet. These deserts form when fresh lava cools into sharp, porous rock that weathers into sand-like grains. Rainfall drains quickly. Plants grow slowly. The terrain feels open, minimalistic, almost lunar. Yet even here, life finds a way. Small tufts of grass take root in cracks. Moss spreads in thin green patches. Birds hop between stones, searching for seeds or insects. A volcanic desert is not barren. It is simply patient. Continue walking, and the landscape softens again. Lava that once cooled into sharp, jagged structures becomes smooth through erosion. Wind rounds edges. Rain carves shallow gullies. Over centuries, water creates small streams that weave through volcanic rock, forming valleys that feel like hidden sanctuaries. Volcanic valleys are some of the most fertile in the world. The soil, enriched by minerals from ancient ash, becomes a cradle for life. Dense forests grow here, tall trees with thick canopies, ferns spreading across the forest floor, delicate flowers illuminated by specks of sunlight drifting through the leaves. Listen closely, and you might hear the gentle trickle of a volcanic spring. These springs emerge where groundwater meets warm layers of rock deep below. Their water is rich in dissolved minerals, creating pools, warm streams, or small waterfalls that feel like nature's quiet exhalations. Some volcanic valleys form around extinct lava tubes. Over time, the ceilings of these tubes collapse, creating natural trenches filled with greenery. Others form where past pyroclastic flows settled into soft, erodible deposits that rain and wind later carved into canyons. Every feature, every valley, ridge, and stream is shaped by processes too slow to witness. And yet, when we observe them today, they appear incredibly peaceful. Now imagine walking across a lava plain, a vast expanse of hardened rock that stretches toward the horizon. These plains form where enormous ancient lava flows cooled into flat fields. The surface is dark, cracked, and textured, with subtle ripples that reveal the direction the lava once flowed. Over time, rainwater collects in shallow depressions, forming tiny pools that glisten in sunlight. Lichens begin to dot the surface with green and yellow patterns. These plains, though formed by fire, become canvases for delicate life. If you continue toward the coastline, you may encounter volcanic cliffs, towering walls of basalt that rise from the sea. Many of these cliffs are made of columnar basalt, tall, hexagonal pillars formed when lava cooled slowly and contracted into geometric shapes. They resemble organ pipes or ancient temples, yet were shaped without human hands. Waves crash gently at their base. Seabirds nest in their cracks. The entire formation feels timeless, as if sculpted by the earth with meticulous, unhurried precision. Beyond the cliffs, volcanic islands form entire worlds of their own. Some islands are lush, filled with tropical forests. Others are stark, young, and rocky. Some sit above hotspots, growing slowly as lava adds new land. Others drift across the ocean on tectonic plates, their volcanoes extinct, but their shapes enduring. These islands are reminders that volcanic activity is one of the planet's greatest creators, not destroyers. Even subtle volcanic features can be beautiful. Small cones rising from plains, old lava channels meandering like frozen rivers, scoria hills outlined against the sky, steam vents releasing gentle wisps of warmth, hot springs glowing turquoise or milky white. Each one is a soft expression of deep geological time. Volcanic landscapes reshape themselves constantly, yet the changes are often so slow that they feel like permanent stillness. A mountain that took 500,000 years to rise appears unmoving. A lava plain that cooled 10,000 years ago feels ancient and eternal. A valley carved by water feels like it has always existed. These landscapes teach us that even powerful forces settle into tranquility. Fire becomes stone, stone becomes soil, soil becomes life, and life becomes forest, meadow, shoreline, and sky. As you drift deeper into rest, imagine these landscapes spreading around you, wide, calm, and ancient. Feel the quietness of volcanic deserts, the cool air of crater lakes, the warmth of springs, the softness of valleys, and the silent strength of volcanic mountains. Everything shaped by volcanoes is shaped slowly. Everything shaped by volcanoes is shaped beautifully. Everything shaped by volcanoes carries the calmness of deep time. Let that calm fill your thoughts as the planet's quiet landscapes guide you gently toward sleep. When we imagine volcanoes interacting with the sky, it's easy to picture ash clouds rising high into the atmosphere. But beyond these rare dramatic moments, volcanoes are engaged in a quiet, constant conversation with the air. This dialogue has shaped Earth's climate, oceans, landscapes, and even life itself, not through sudden bursts, but through millions of years of steady, delicate contributions. Tonight, let's drift upward from the ground into the atmosphere, exploring how volcanoes breathe into the sky in ways that are slow, balanced, and surprisingly gentle. Imagine standing beside a calm volcano at dawn. The air is cool, the sky a soft gradient of blue and gold. No eruption is happening. No ash is rising. Yet if you look closely at the summit, you may see a thin wisp of steam, so faint it's barely visible. This is not smoke. It is not a sign of danger. It is the volcano exhaling, releasing tiny amounts of heat and gas formed deep within the earth. Volcanoes emit gases constantly, even when they appear completely still. Most of these gases have been inside the planet for millions of years. Their journey upward is as slow as magma's ascent through the crust, and their release at the surface is often so soft that it merges effortlessly with the air. The primary gas volcanoes release is water vapor, simple steam, rising from the interaction between magma and groundwater. Many people don't realize that volcanic plumes are mostly made of water, not ash or fire. When this vapor enters the cool atmosphere, it forms tiny droplets or ice crystals, building gentle white clouds that drift away quietly. The next most common gas is carbon dioxide. In our daily lives, CO is associated with many things. But in natural history, volcanic carbon dioxide has played an essential role. Long ago, before plants covered the earth, volcanic CO warmed the planet enough to sustain oceans and life. Even today, volcanic CO output is modest compared to human sources, but still essential in the natural carbon cycle. Imagine CO drifting upward from a volcano's vents, rising like invisible threads that eventually blend with the global atmosphere. It moves slowly, mixing with air currents, becoming part of weather patterns. Even on days when the sky is silent, this exchange continues, delicate and steady. Volcanoes also release sulfur dioxide, another gas that quietly influences the atmosphere. When sulfur dioxide reaches the stratosphere, which only happens during significant eruptions, it can reflect sunlight, slightly cooling the Earth for a year or two. But most sulfur dioxide stays close to the ground, where it reacts with moisture to form tiny droplets of sulfate. These droplets act as seeds for clouds, helping them form and grow. Think of clouds drifting across a volcanic landscape. Some of them owe their existence to microscopic particles released by past eruptions. Every cloud that passes over a mountain carries within it fragments of volcanic history, minerals, droplets, or ions that began deep within the Earth. Volcanic gases also interact with rainfall. When water vapor condenses around sulfate particles or ash, rain becomes enriched with minerals that nourish the land. Far from being harmful, this natural process has helped create fertile regions around the world. Volcanic rainfall delivers iron, sulfur, and nitrogen compounds that feed forests, crops, and lakes. And then there is steam, released through fumaroles and vents. Steam rising from volcanic areas is one of the quietest and most soothing sights in nature. It curls into the air in soft spirals, dissolving almost instantly. These steam plumes form because groundwater meets warm rock, not because magma is near the surface. They represent warmth radiating through stone, emerging to meet the sky. Walk through a volcanic field with steam vents, and the world feels meditative. Warm, mineral-rich water evaporates into mist. The air smells faintly of earth and rain. Plants adapted to the warmth grow nearby, their leaves glistening with humidity. Everything feels gentle, even though the heat originates from deep within the planet. Some volcanic landscapes also host geysers, natural fountains of water driven by underground heat. While geysers can erupt with surprising force, the intervals between their activity are calm. Hot water circulates slowly underground, heated by magma chambers that rest far beneath the surface. The calmness of these cycles, heating, rising, cooling, falling, mirrors the slow breathing of the Earth itself. In Iceland, New Zealand, and Chile, geothermal fields hiss softly, releasing steam like whispered sighs. These sites are reminders that volcanic activity is not always explosive. Often, it is a gentle release of energy that eventually joins the sky as warm moisture. Even hot springs play a role in connecting volcanoes to the atmosphere. Rising steam enriches the air with minerals. Warm pools release tiny amounts of gas that drift upward harmlessly. Birds gather near the springs, warmed by the mist, while moss spreads in vibrant green carpets nearby. The entire environment feels like a warm exhale from the planet, peaceful, restorative. But volcanic gases don't only shape the atmosphere today. They played a profound role in Earth's early evolution. 4 billion years ago, the Earth's sky was not blue, but hazy and thick. Volcanoes released water vapor, carbon dioxide, hydrogen, nitrogen, and sulfur compounds that eventually formed the atmosphere we breathe today. Rain fell for the first time because volcanic steam condensed. Oceans filled because volcanic water vapor accumulated over millions of years. The golden sunlight filtering through the early atmosphere was warmed by volcanic greenhouse gases, creating temperatures suitable for liquid water. Without volcanic gases, life might never have emerged. Even now, deep-sea volcanoes, hidden beneath the ocean, continue this ancient process. Hydrothermal vents release warm, mineral-rich water that mixes with the cold ocean around them. These vents emit gases like hydrogen and methane, providing energy for unique ecosystems completely independent of sunlight. Imagine black chimney-like structures at the ocean floor, releasing gentle streams of warm fluid in the darkness. Around them, strange creatures thrive. Tube worms, blind shrimp, glowing bacteria, all supported by chemistry instead of photosynthesis. This quiet world, far from the surface, is sustained by volcanoes whispering into the deep waters. Volcanoes also create tiny particles called aerosols, which drift through the sky like invisible dust. These particles influence cloud formation, reflect a small amount of sunlight, and help regulate the planet's temperature. They are part of the Earth's natural cooling and warming cycles, maintaining balance over long periods. Even ash, once settled in the atmosphere, becomes part of cloud seeds or nutrient carriers across continents. Dust from volcanic eruptions has fertilized rainforests, fed distant oceans with iron, and helped shape monsoon patterns. Every volcanic contribution, from steam to aerosols, becomes part of a larger symphony of sky and climate. And this symphony is quieter than we imagine. Most of the time, volcanoes breathe gently, releasing gases so slowly that they blend seamlessly with the air. Most of the time, their influence is subtle, a trace of sulfate here, a hint of carbon dioxide there. Most of the time, their presence is invisible. Yet without this quiet, persistent connection, Earth's atmosphere would be very different. As you imagine volcanoes interacting with the sky, picture soft plumes of steam rising at dawn. Picture clouds forming around tiny mineral particles. Picture rain enriched by volcanic ions nourishing a forest. Picture distant high-altitude winds carrying microscopic volcanic dust across oceans. The atmosphere and volcanoes are partners in a long, slow dance, one that shapes climate, land, life, and even the rhythm of Earth's seasons. Let this thought settle deeply within you. The same sky you breathe has been shaped by volcanoes for billions of years. Every breath carries molecules that once rose from deep within the Earth. Every cloud contains stories written by ash and vapor. Every sunset is painted through an atmosphere touched gently by volcanic minerals. As you drift deeper into rest, feel the calmness of this ancient connection. The Earth breathes into the sky softly, steadily, continuously. And tonight, as you breathe slowly, your rhythm mirrors the planet's, quiet, balanced, timeless. When we think of volcanoes, it's easy to imagine barren landscapes, fields of cooling lava, and silent ash-covered valleys. But the true story of volcanic environments is one of renewal. Life returns sooner than we expect, in places where the earth is still warm, the soil still young, and the terrain shaped by fire. Over years, decades, and centuries, volcanoes become cradles of biodiversity, places where plants pioneer, animals adapt, and entire ecosystems rise from what once looked like devastation. Tonight, we wander through these reborn landscapes, exploring how quietly and beautifully life reclaims volcanic ground. Imagine a volcanic slope shortly after an eruption. Everything is quiet. The rocks are still warm. A fine layer of gray ash covers the land like a blanket of soft dust. At first glance, nothing seems alive. But if you kneel down and look closely, you might see the earliest signs of life returning. Tiny green shoots pushing through cracks in the cooling lava. These first pioneers are often mosses, lichens, and hardy grasses. They don't need rich soil. Instead, they help create it. Lichens cling to bare rock, releasing mild acids that slowly break it down. Mosses capture moisture, holding it long enough for microscopic organisms to gather. These are the quiet architects of new ecosystems. As years pass, the volcanic soil begins to form, soft, dark, and incredibly fertile, enriched by minerals from deep within the earth. Volcanic soil contains potassium, calcium, magnesium, iron, and trace elements that plants adore. The transformation is slow but constant, driven by rainfall, sunlight, and microorganisms you can't see with the naked eye. Soon, more plants arrive. Ferns unfurl their delicate fronds. Small shrubs take root. Seedlings from nearby forests drift in on the wind. One of the most famous examples of this transformation happened at Mount St. Helens. After its 1980 eruption, the surrounding region looked lifeless. But within a single growing season, lupins, bright purple wildflowers, began spreading across the ash. These plants don't just beautify the landscape. They fix nitrogen, an essential nutrient, into the soil. Their presence makes it easier for other plants to follow. Volcanic landscapes are full of such plant heroes, species specially adapted to grow where the ground is new. On volcanic islands like Hawaii, you can trace stages of ecological succession simply by walking from the newest lava flows to the oldest. The newest flows may host only lichens. Slightly older ones support ferns and grasses. Older flows become home to bushes and young trees. Eventually, full forests rise thick and lush. This progression shows how life works hand in hand with volcanic rock to create habitats teeming with biodiversity. Now imagine walking into a forest that grew on ancient lava. The soil beneath your feet is springy and rich. The trees are tall, their roots anchored in layers of decomposed plants and minerals, once carried upward by magma. These forests are often more vibrant than those in non-volcanic regions. Volcanic nutrients offer plants everything they need to thrive. In places like Java, Costa Rica, and Japan, lush rainforests owe their vitality to ash and lava from centuries past. Animals soon follow the plants. Insects arrive first, beetles digging into the soft ash, butterflies hovering near pioneer flowers, ants carving tiny tunnels through newly formed soil. Next come birds, some searching for seeds, others for insects. Birds often help spread plant life by carrying seeds from older forests into younger volcanic ones. A single bird dropping can introduce a species that transforms an entire area over decades. Small mammals return as food becomes more abundant. Rabbits, mice, and foxes explore the terrain. Deer nibble at young plants. Bats roost in lava tubes, which offer cool, safe shelters. Speaking of lava tubes, these underground passages created by ancient flows play a subtle but crucial role in volcanic ecosystems. Inside lava tubes, temperatures remain stable year-round. Moisture drips slowly from the ceiling. Fungi and bacteria thrive in darkness. Insects evolve unique traits to survive here. Some lava tubes harbor blind insects and spiders found nowhere else on Earth. Tiny creatures that adapted to these lightless sanctuaries over thousands of years. These ecosystems are some of the most delicate and mysterious on the planet. Now travel with your imagination to Iceland, where volcanic landscapes cover wide stretches of the country. Geothermal heat warms the ground beneath the snow, creating pockets where plants bloom earlier in the season. Arctic foxes wander between volcanic rocks. Seabirds nest along basalt cliffs. Life finds warmth in places shaped by fire. Or picture Japan, where forests flourish on volcanic slopes. Animals like the Japanese siro, a gentle, goat-like creature, climb steep terrains shaped by lava. Hot springs formed by geothermal heat offer bathing spots for monkeys during winter months. These springs exist only because volcanic warmth heats groundwater deep underground. Volcanic landscapes are full of surprises. In tropical regions, volcanic ash feeds coral reefs. Rain washes nutrients into rivers, which carry them to the sea. Coral thrives when it has access to minerals, growing into bright underwater worlds that eventually support turtles, fish, and seabirds. On land, volcanic soils give rise to agriculture that feeds entire civilizations. Coffee plantations in Hawaii, rice fields in Indonesia, vineyards near Mount Etna and Vesuvius, banana plantations in Costa Rica, tea fields on volcanic slopes in Japan. Farmers throughout history have understood what volcanoes offer: soil so rich that crops grow stronger, sweeter, more abundant. And all of this begins with eruptions that might last only hours, days, or weeks. Fire becomes ash. Ash becomes soil. Soil becomes life. This cycle of destruction and renewal is the heartbeat of volcanic ecosystems. Some of the most extraordinary examples come from volcanic islands formed entirely by eruptions. When an island first rises from the sea, black, rocky, steaming, it appears utterly lifeless. But within months, seabirds begin to land on its shores. Their feathers, droppings, and food scraps bring nutrients. Seeds stick to their feet. Plants begin to grow. Insects follow. Over time, what was once just a mound of solidified lava becomes a green, thriving sanctuary. In 1963, a new volcanic island named Surtsey emerged off the coast of Iceland. Scientists observed its transformation closely. Within a few years, birds arrived. Moss covered some areas. Grass began to grow. Today, Surtsey is home to hundreds of species, all arriving without human intervention. It's a reminder that life is drawn to volcanic landscapes, no matter how new or bare they seem. Volcanoes also create unique habitats known as savannas, where grasslands spread across nutrient-rich plateaus. Grazing animals take advantage of the endless grasses, and predators follow them. The entire ecosystem becomes shaped by the mineral-packed soil left behind by ancient eruptions. Even more remarkable are species that adapt to volcanic heat. Certain plants tolerate warm soil temperatures. Some insects drink from hot springs. Bacteria live in boiling geothermal pools, thriving in conditions that would harm most life. These extremophiles help scientists understand how life might exist on other planets. In this way, volcanoes become not just creators of ecosystems, but teachers of biological resilience. Walk slowly through a volcanic forest in your imagination. Feel the soft soil. Smell the rich scent of earth and minerals. Hear the distant chirping of birds. See sunlight filtering through leaves that grew from ground once covered in lava. Everything around you, every leaf, every animal, every sound, is part of a long story of renewal. Volcanoes teach us that life is patient, life is adaptable, life is resilient, and life often grows strongest where the earth once burned brightest. As you rest deeper into the quiet of the night, let this idea comfort you. Even in the aftermath of fire, the world rebuilds itself gently. Ash becomes nourishment. Rock becomes shelter. Heat becomes life. And volcanic landscapes, shaped by deep time and slow transformation, become some of the most peaceful environments on Earth. Volcanoes are often thought of as dramatic forces, shaping the planet with fiery eruptions and rivers of molten rock. But beneath that image lies a deeper truth. Volcanoes are among the greatest keepers of time on Earth. They record the planet's history in layers of stone, rhythm, pressure, and chemistry. They mark the passage of eras. They hold memories of ancient oceans, shifting continents, long extinct forests, and climates forgotten by humanity. Tonight, as we drift into this final chapter, we explore volcanoes not as events, but as archives, quiet storytellers of deep time. Imagine standing at the base of a tall volcanic mountain. Its slopes rise slowly toward the sky, shaped by countless layers of cooled lava and ancient ash. Each layer represents a moment in Earth's past, not a moment measured in minutes or hours, but in centuries, millennia, even millions of years. To walk around a volcano is to walk through a history book written in stone. Volcanoes grow in cycles. An eruption sends lava outward. The lava cools into rock. Wind and rain slowly wear that rock down. Vegetation takes root. Animals explore its slopes. Time passes quietly. And eventually, deep below, pressure builds again. Each cycle can take hundreds or thousands of years, but together they create landscapes that feel ancient and grounded. Volcanoes do not rush. Their growth is steady and patient, like the slow rise and fall of a planet breathing. Now imagine slicing through a volcanic mountain the way a geologist might examine its layers. Some bands of rock are dark and dense, formed when lava cooled quickly. Others are lighter, full of tiny bubbles, signs that gas escaped as the lava hardened. Some layers contain ash from distant eruptions, carried by wind and gently deposited over time. Others contain minerals that crystallized slowly beneath the surface before being pushed upward. These layers can reveal how hot the magma was, how long it took to cool, what kinds of minerals formed, how much gas was trapped, what the surrounding climate was like, which plants and animals lived nearby. Whether the eruption was gentle or explosive, volcanoes preserve details that would otherwise be lost to time. The lava itself tells part of the story. Basalt, the most common volcanic rock, forms wide plateaus and ocean floors. It cools into smooth surfaces or hexagonal columns that pattern the landscape like natural mosaics. Andesite, found in stratovolcanoes, reveals more complex chemistry. Rhyolite, often associated with ancient eruptions, can form glassy surfaces like obsidian or ash-soft tufts. Each type of rock is a page in Earth's memory. Now imagine how volcanoes store these memories beneath the ground as well. Magma chambers, though unseen, are constantly recording changes in composition, temperature, and pressure. As magma mixes, crystals form and dissolve, creating patterns like rings inside a tree trunk, patterns that scientists can read to understand a volcano's long internal evolution. Even minerals carry stories. A single crystal of zircon can survive for billions of years inside volcanic rocks, recording chemical clues about the temperature and chemistry of Earth's interior at the moment it formed. These crystals are older than mountains, oceans, and many continents. Volcanoes are silent librarians of geological history. But they also keep time in another way, by shaping the planet's surface itself. Consider mountain ranges formed by volcanic arcs. Over millions of years, tectonic plates move, collide, and separate. Volcanic arcs rise, erupt, crumble, and erode. Entire landscapes emerge and disappear. Through these cycles, volcanoes become markers of plate movements, carving paths across continents and oceans. In the Pacific Ring of Fire, volcanoes trace the edges of deep ocean trenches. In East Africa, volcanoes mark the slow tearing of a continent apart. In Hawaii, volcanoes form stepping stone islands that reveal the movement of the Pacific Plate across a mantle hotspot. Volcanoes become fingerprints of Earth's long tectonic dance. Now imagine time moving even more slowly. Not centuries or millennia, but millions of years. A volcano erupts. It grows. It sleeps. It erodes. Wind carves its slopes. Rivers cut through its rocks. Animals walk across its cooled lava. Plants grow, die, and become soil. The landscape changes shape, and eventually the volcano becomes almost unrecognizable. Some volcanoes disappear entirely, leaving only their roots, hardened magma deep within the earth. These remnants, called volcanic plugs or dikes, stand like ancient guardians above the land. Devil's Tower in the United States, Sugarloaf Mountain in Brazil, and Edinburgh's Arthur's Seat in Scotland are all remnants of volcanoes that once towered higher than anything around them. They are monuments to deep time. Volcanoes also act as clocks for climate. Ash layers and ice cores show when ancient eruptions occurred. Pumice deposits reveal past sea levels. Volcanic aerosols trapped in glaciers tell of cooling events long before written history. By reading these signs, scientists can reconstruct past climates, warm periods, ice ages, sudden shifts, and understand how Earth's atmosphere has evolved. Volcanoes help us remember the world before humans existed. Now shift your imagination to the ocean floor, where underwater volcanoes constantly create new crust. These submarine volcanoes are silent and dark, forming pillow lava domes and ridges that stretch across the ocean like giant scars. Their activity is steady, producing new sea floor at a rate measured in millimeters per year. As plates move apart along mid-ocean ridges, volcanoes fill in the gaps. The ocean floors we see today were once molten rock released gently from underwater vents. Even the Earth's magnetic field leaves its imprint on this new crust, recording reversals in polarity, like stripes on the seafloor. These stripes allow scientists to measure the age of the ocean, another kind of volcanic timekeeping. Volcanoes help us measure the heartbeat of the planet, but perhaps the most peaceful expression of volcanic time is seen in the way ecosystems evolve on volcanic ground. Fresh lava becomes bare stone. Bare stone becomes ash. Ash becomes soil. Soil becomes a meadow. A meadow becomes a forest. A forest becomes a habitat for thousands of species. This sequence unfolds over centuries, yet it begins with the quiet cooling of molten rock. Multitudes of plants and animals live today because volcanoes created the soil they depend on. Life itself is intertwined with volcanic time, and volcanic landscapes hold stories older than humanity itself. Some volcanoes erupted long before our ancestors existed. Some formed islands that later became homes to early civilizations. Some shaped the climates that determined human migration. Some created mineral deposits used by ancient cultures. Volcanoes are companions to human history, even when we don't notice. Now picture yourself standing at the edge of a caldera at sunset. The sky glows orange and pink. The lake below reflects the quiet light. The crater walls, shaped by distant eruptions, rise gently around you. Everything feels timeless. You are standing inside a memory, one preserved in stone, water, and silence. Volcanoes are reminders that the earth is always changing, always moving, always breathing in rhythms far slower than our own. Their eruptions may be sudden, but their true nature is patient. Their stories are long. Their memories stretch back to the planet's beginnings. As you breathe slowly, feel how your rhythm aligns with the planet's. Your breath mirrors the slow rise of magma. Your heartbeat matches the steady growth of volcanic mountains. Your stillness echoes the long pauses between eruptions. Your presence becomes part of Earth's deep time calm. Volcanoes are timekeepers, memory holders, sculptors of the planet's past and future. And though their stories are immense, they unfold quietly, layer by layer, grain by grain, drop by drop of molten rock. Tonight, as you rest, remember this. You are lying on a world that has been shaped for billions of years. A world built slowly, peacefully, patiently. A world where even fire becomes stone, and stone becomes soil, and soil becomes life. As our gentle journey through the world of volcanoes comes to a close, allow everything you heard tonight to settle softly within you. From the first quiet stirrings of magma deep beneath the earth to the still silhouettes of volcanoes resting under the sky, each moment has told a story of patience, balance, and deep, ancient calm. You've wandered through peaceful craters, crossed cooled lava fields, admired serene lakes held within old calderas, and watched life return to places once covered in ash. You've listened to the soft conversation between volcanoes and the atmosphere, warm steam rising, delicate minerals drifting into clouds, tiny particles shaping future rains. And you've walked beside geological time itself, a rhythm far slower and more grounded than anything in daily life. Now, as you prepare for sleep, imagine yourself standing once more in one of these tranquil volcanic landscapes. Picture a quiet mountain beneath a star-filled sky. The air is cool, the earth steady beneath your feet, the world around you moving only in small, gentle breaths. Nothing is rushed, nothing is urgent. The planet simply exists, calm, ancient, comforting. Feel that stability inside your body. Feel your breath slowing. Feel your muscles unwinding. You are safe here. You are peaceful. You are ready to rest. Let these mountains of fire, silent now, patient and timeless, watch over your sleep tonight. Good night. May your dreams be soft, warm, and deeply restful.